Hey everybody, this is Systems of Human Performance. What I wanted to do today is give you an audio appendage, an audio addition to this week's article. If I have enough time to do this in the future, or I want to do it in the future, I will do this for all upcoming and future articles. But for now, I'll do it for this one and see how you all like it. So the article title is Diagramming Customer Wants and Expectations, Systems Thinking for Product Design Using the Kano Model. So I'm just going to read through this and I'll annotate if I want to as I go. I usually write about operations, even when discussing topics like design, human-machine interfaces, user experience, and the like. I almost always put this into the context of industrial systems. This is chiefly because of two reasons. First, there are ample examples to take from these environments that are not usually encountered. God forbid I write an article looking at the cliche of iPhone interface design. We've all read those articles. The second reason is because of my background. My work exposes me to these environments, warehouses, manufacturing plants, control systems, and so on and so forth. My work has taught me to communicate in processes, flows, constraints, and feedback loops. So it's only natural that I pull from inspiration from the same source. So therefore, over the next few articles, I'm going to shift my focus to discussing product design and the systems we can use to create, analyze, and optimize product design. What you'll find is that the product design is not so foreign after all. In fact, it's fertile ground for optimization with systems thinking. Product design has inputs, it has feedback mechanisms, it has constraints, and it produces an output that either delivers value or doesn't. The tools are different, there are different frameworks, new vocabulary, but the underlying logic is cogent and familiar. Over the next 4 weeks, I'm going to walk through the product design process the way I'd approach any system, methodically, from the outside in. We'll start with where every well-designed system starts, with the customer. As we know, everything we should do should be thought of in terms of value, and the value we're delivering to somebody. In this case, since it's a product, we'll start with the customer. Customer wants and expectations. Here's an uncomfortable truth. Customers don't know what they want, and they have an even harder time expressing what they want. This is a reality of how people experience products. Most of us can tell you when something isn't working. We can tell you when we're frustrated, confused, or delighted. But ask someone to articulate exactly what they want in a product before it exists, before they ever interact with it, and you're going to get a pretty shallow answer. One that is coded with their prior experiences and what they've seen on the market, and one you probably can't act upon. Henry Ford supposedly said that if we have asked people what they wanted, they would have said faster horses. People articulate wants within the frame of what they already know. They're not designing the product, but instead merely regurgitating their own current experience. This creates a real systems problem. If the inputs to your design process are unreliable, like if the voice of the customer is noisy, incomplete, or just flat out wrong, then everything downstream is compromised. Your design decisions are built on a shaky foundation. So how do you fix the input? You stop asking open-ended questions and start asking structured ones. And more importantly, you stop treating all customer wants as equal because they're not. And here's where we enter the Kano model. Here's a picture, by the way, of me with Professor Kano. The Kano model. The Kano model, developed by Japanese quality researcher Noriaki Kano in the 1980s, is one of those tools that sounds simple until you sit with it for a while. On the surface, it is a 2x2-ish diagram that maps product attributes against customer satisfaction. But what it's really doing is something more valuable. It's giving you a taxonomy of value. As I said, here's a picture of me hanging with him in Philadelphia on a spring morning in 2024. The key takeaway of the framework is not all product features deliver value the same way. Some features delight customers, while others are expected and invisible until they fail. And some are simply performance levers, where more is always better. Treating these three categories in the same way is a design mistake. So now I'm going to go through each of these three categories. Dissatisfiers and table stakes. Dissatisfiers are the product attributes a customer expects unconditionally. They don't create satisfaction. Their presence is assumed and their absence is catastrophic. Think about it this way. The ignition system in your car must start every single time. A new laptop must connect to Wi-Fi. A tire must hold air. If you ask a customer what they want in a vehicle, they will not tell you that they want it to start. A hotel does not bring in now with fresh sheets and clean bathrooms. No customer is going to thank you for these things, but they will absolutely destroy you in reviews if you don't do them. What makes dissatisfiers tricky from a system standpoint is that they represent a hard floor that you have to meet. Failing here isn't a competitive advantage, it's table stakes to get into the marketplace to begin with. Using another business framework, you might have heard these called barriers to entry. Mapping these dissatisfiers to the Kano diagram, dissatisfiers live in the lower right quadrant because even exceptional performance of these attributes produces little additional satisfaction, but any degradation in performance drives satisfaction off a cliff. Now, if you're not on the article, it's very helpful to kind of have this picture here. But essentially we have kind of like a coordinate plane, like you are familiar with from your Algebra 1 class. On the x-axis, on the horizontal axis, you have a spectrum of moving from left to right, poor performance to exceptional performance. From left to right, exceptional performance is on the right, poor performance is on the left. In your vertical axis, you have customer being dissatisfied in the bottom part and customer being extremely satisfied in your top part. So what you now have here is you're going to superimpose these different categories of product attributes based on how they satisfy the customer. As we mentioned, when we're talking about dissatisfiers or table stakes, they are going to fall in kind of quadrant 4, where regardless of your performance level of these things, anything less than exceptional performance is going to dissatisfy the customer. And you're never going to satisfy the customer. We're never going above kind of this midpoint for satisfaction by addressing these dissatisfiers, by these table stakes. Okay? We'll return to this diagram when we map on the other delighters. Well, I guess we can talk about them right now. The delighters is these product attributes that we're just about to talk about. They are your proverbial bells and whistles, and really, regardless of the performance, if you add these things on, they're going to satisfy the customer in some particular way. And then what you really have, but there's going to be a limit to what you can satisfy them with, right? Is because why we actually buy products are these things called performance attributes, which are essentially more equals better. And we'll talk about those, but essentially, I rather have a car with more fuel efficiency, with more cargo space, with more safety, and so on and so forth, right? Is I'm competing on these performance attributes, and the better they perform, the more satisfied the customer is. Okay, and then lastly, in this diagram, I have this very kind of transparent arrow of time, which says these things which once delighted the customer will eventually be things that we compete against based on performance, and eventually they will become table stakes. They will be required. They will be expected by the customer. So I'll end up repeating myself if I just keep talking about this. We're going to move ahead into the delighters category. On the opposite end of the spectrum are the delighters. Delighters are the proverbial bells and whistles on a product. Customers didn't know they needed them until they experienced them. What makes them fascinating from a systems perspective is the nonlinear relationship between their performance and customer satisfaction. Consider the early days of parking assist in automobiles. The features didn't work flawlessly, the process was clunky, imprecise, and honestly kind of annoying in tight spots, but customers loved it anyway. Why? Because its presence alone was novel and exciting. The delight came from the inclusion of the feature, not from the feature's performance. That's the signature of a true delighter, a relatively flat satisfaction curve on the performance axis, sitting well above the neutral line on the satisfaction axis. The same logic applied to lane assist and brake assist when they first rolled out. You were delighted simply when the car was attempting to help you. Perfection was not required. Referencing the diagram again, we see that the delighter is mapped to the upper left quadrant, like I talked about. Performance attributes. Performance attributes are between delighters and dissatisfiers. Those are the most intuitive of the three categories of the product features, or what I would call product attributes. Here is where you genuinely compete. In this dimension, more is genuinely better. More horsepower, better fuel efficiency, lower price, faster processing speed. These are all performance attributes. Customers notice and appreciate incremental improvements, and they notice and are frustrated by incremental declines. Without high performance in these areas, customers will not be interested in your product no matter how many delighters you tack on, right? So I can have all these bells and whistles, but if my car is not fuel efficient and does not have good horsepower and is too expensive, I'm not going to get any sales. Time keeps on slipping into the future. Here is where the Kano motto gets really interesting and where a systems thinker could pay close attention. The categories are not static. They vary with time. There is an arrow of time embedded in this diagram, and it points in from delighter towards dissatisfier. Consider automatic windows in a vehicle. When they were first introduced, they were a luxury feature. They were a delighter, something that distinguished high-end vehicles from economy models and made drivers feel like they were getting something special. Today, you can't buy a car without them. They've drifted from delight to expectation. The same is true for backup cameras and remote starts and airbags and even fuel efficiency. The same thing with cell phone coverage has happened. Carriers used to advertise on the number of dropped calls, treating network reliability as a performance attribute, where the more coverage meant more satisfaction. Verizon's "Can you hear me now" guy was once a reassurance of performance. Now the very idea is absurd. Today, any dropped call is a failure. Coverage has migrated all the way from performance attribute to table stake. The drift follows a predictable pattern, and the Kano model makes it visible. For a systems thinker, this is critical information. The system's requirements are not fixed, they evolve. What delays today becomes expected tomorrow. If your product development system doesn't account for this, you will fall behind, not because of the competition and them out-innovating you, but because the ground has shifted beneath you while you were standing still. From theory to measurement. The Kano survey. Here's where most presentations of the Kano model stop, and it's a problem. The diagram is conceptually elegant, but we need a playbook for action, not just a framework. To make the Kano model operational, you need a structured way to collect and classify real customer input. The mechanism is the Kano survey. Most market research, like pricing sensitivity, demographic segmentation, and brand perception, tells you a lot about the customer, but very little about the customer's relationship to the product itself. The Kano survey is designed to close that gap. The key structural innovation of the Kano survey is the statement pair. For each product attribute you're investigating, you ask respondents two questions: a functional version, such as the carpet cleaner is easy to maneuver, and a dysfunctional version. The carpet cleaner is not easy to maneuver. For each statement, respondents select from a 5-point scale of like, expect, don't care, can live with, or dislike. The power of the paired question format is that it gives you signal in both directions. You learn not just how the customer feels when the feature works, you also learn how they feel when it doesn't. And those two responses together, when run through a standardized logic matrix, tells you which category the attribute belongs to. So what I have here in the video and on the article is your Kano survey logic matrix. So essentially we have this very helpful, very mimetic Kano framework on our coordinate plane. how do we actually take a real-world product that we either have in the marketplace now or in development, and how do we say which features are important to the customer in terms of a qualifier or in terms of in terms of a must-have and a dissatisfier, or in terms of a performance category, or in terms of in terms of a delighter, and so on and so forth. What you can do is you can ask these two paired questions, one phrased as a positive, the product does X, and then one as a negative, the product does not do X. And then by comparing these responses against this matrix, it will tell us what each of these product categories that we're investigating, product attributes that we're investigating, where they fall on our Kano diagram. So the logic matrix above is a table that cross-references the functional and dysfunctional responses and outputs a classification. In this matrix, we have A is attractive, so a delighter. M is a must-have, so a dissatisfier. P is a performance. I is indifferent. They don't care one way or the other. And then R is a reversal, and Q is questionable. Reversals are interesting, by the way, because it tells you that what you perceived as function was actually dysfunction, and what you perceived as dysfunction was actually function. So you assumed incorrectly on what the customer cares about. That's actually what I say in the next the next paragraph here. The reversals are worth calling out specifically because they're counterintuitive and genuinely informative. A reversal happens when a respondent prefers the dysfunctional version of a product's attribute. In other words, they actually want what we would normally consider the failure mode. This can happen for real reasons. Some customers may prefer manual controls over automated ones, who value simplicity over features, who experience the improvement as noise rather than signal. Once survey responses are collected across your respondent pool, you reconcile disagreements by assigning the dominant classification. The most frequently coded response for a given attribute becomes the classification for the attribute. So you're going to do this not just to one participant, but to 50 participants or so on and so forth. And these participants are going to have varying degrees they're not always going to agree on the same thing, right? Their logic matrix is going to be different from their someone else in their cohort. You're just going to aggregate them and figure out who has what the dominant mood is for each of these product attributes. The result is a populated Kano diagram. Each attribute sits in its appropriate zone, giving your design team a visual map of what the product must do, what it should do better, and what might create genuine competitive separation. I've done this several times in my work. Here's an example of a final Kano diagram talking about a new vacuum cleaner, or maybe it was carpet cleaner. For brevity's sake, I won't include the survey results in the questions, but you can see here that essentially I didn't find in my survey any disqualifiers. There were a number of delighters over here, such as low weight and one-pass cleaning, but where we needed to compete was actually in the maneuverability of the carpet cleaner, vacuum cleaner, and the confined spaces. So what we'll talk about next week as well is some of these product trade-offs. Can I actually get something that is maneuverable and low weight, or is maneuverable and works in confined spaces, or is resilient to braking? We'll talk about that next week. What this means for systems thinker, this is kind of the conclusion. The Kano model is a great starting place if you want to treat product design systemically. Customer wants are the primary input to any product design system. Without structure, the input is vague, inconsistent, and subject to cognitive bias. With the Kano model its accompanying survey, you can convert qualitative customer sentiment into categorized, prioritized, actionable data. You can distinguish between what the product must do, what it should do better, and what it might do to surprise and delight. And you can do all of this before a single engineering decision is made, which is exactly where this kind of intelligence should sit, from the front of the process, upstream, informing everything that comes after. That's the value of the Kano model. The Connell model isn't just a customer satisfaction tool, it's a boundary condition setter. It tells your design system what the environment demands of it so that the system can be designed to respond accordingly. As I mentioned, next week we'll move downstream into the design trade-offs that inevitably emerge once you know what the customer actually wants. Because knowing what they want and being able to deliver it are two very different problems, and the gap between them is where real design thinking lives. So, as always, if we finish this article, please subscribe, please leave a comment, please share this with just one other friend. I really appreciate it. I'm trying to grow this channel, and anything you do to boost it in the algorithm really, really helps me. I hope you enjoyed this article. The Kano diagram is one of my favorite topics to talk about. I don't like, just kind of talking about tools to talk about tools, but I think here in the context of systems thinking and product design, it's a very good fit for what we're talking about. I hope you enjoyed this, and I hope to be doing this for the next article.